Okay, hi everyone. Today topic is solid state, physical chemistry. Solid state we have taken. So what is solid? First, any substance whose melting point is above room temperature. Any substance whose melting point is above room temperature at atmospheric pressure is called solid. That is called solid. Some general characteristics of solids are given here. General characteristics of solids. We know this general characteristics. Once again you listen. First one, solids have definite shape and definite volume. Definite shape and definite volume. Next one, solids are almost incompressible. Solids are almost incompressible. Solids are almost incompressible. In solids, particles position is fixed. The position of the particles are fixed in solids. They don't move. The particles which are present in solid, that particles position is fixed. The position of the particles are fixed. Next one, solids have high density. Solids have high density compared to liquids and gases. Solids have high density. Next, in solids, intermolecular distances are short. Intermolecular distances are very short in solids, whereas in compared to liquids and gases, in solids intermolecular distances are very short, means particles are very close. Intermolecular distances are short. Next one, intermolecular forces are very strong in solids. Intermolecular forces means the attractive forces between the particles which are present in solids are very strong. So intermolecular forces are strong. Intermolecular forces are strong. And these are the characteristics of solids. General characteristics of solids. Next, solids are made up of particles, maybe atoms or ions or molecules. Solids are made up of particles. That particles may be atoms or ions or molecules. Depending on the arrangement of particles and the properties of that particles, solids are classified into two types. First one is true solids. True solids, or these are also called crystalline solids. Crystalline solids. Second type, pseudo solids. Pseudo solids are amorphous solids. So amorphous meaning is shapeless solids, and pseudo solids, these are true solids, these are false solids. Pseudo meaning is lie. So true solids, false solids. Crystalline solids and amorphous solids. Crystalline solids example we are written here, sodium chloride, and for amorphous solids example glass. Now we will study about this true solids and pseudo solids. We will study first differences. What are the main differences between these true solids and pseudo solids? Okay. Now see differences between crystalline solids and pseudo solids, or they are also called amorphous solids. Amorphous solids. So you write here amorphous solids. Now crystalline solids are those in which particles follows long range order. Particles follows long range order. Long range order means in the solid only one pattern is repeated entire the solid. Entire the crystal only one pattern is repeated, that is called long range order. Same pattern is repeated entire the crystal. Amorphous solids are those in which particles follows short range order. Short range order means some distance one pattern is present and some distance another pattern will be present. That is called short range order. And crystalline solids have sharp melting point. But amorphous solids have diffused melting point. Means sharp melting point means crystalline solids melts at a particular temperature. At a particular temperature crystalline solid undergoes melting, but amorphous solids undergoes melting in between some temperatures, that is called diffused temperature. For example, one metal temperature we have taken 200 degrees Celsius. At that temperature only that will be melted. But amorphous solids temperature melting point is given like this, 200 to 250 degrees Celsius, means in between the temperature that will be melted. So sharp melting point because all bonds in crystalline solids will be broken at a time. That's why they have sharp melting point. But here they will not broken at a time. All bonds will not be broken at a time. That's why it is called diffused melting point. And when we cut the crystalline solids, that gives two sharp edges. Sharp edges pieces are formed when we cut with a knife these crystalline solids. Sharp edges will be formed by cutting the crystalline solids. But amorphous solids gives irregular cuts. Irregular cuts are formed. When we cut these amorphous solids, that gives irregular cuts containing pieces are formed. But here sharp edges containing pieces are formed when we cut these crystalline solids. So next difference, sharp melting point and sharp edges. And next one is they have definite shape and definite geometry. These crystalline solids have definite shape and definite geometry. But amorphous solids have irregular shape and geometry. Next one, these crystalline solids are hard and brittle. Brittle means they are breakable. They are hard but breakable, like salt. Example, NaCl, sodium chloride, salt only, table salt. And here these are supercooled liquids. Supercooled liquids, best example glass. Glass is the supercooled liquid example. And next one, very important difference one is given here. Next very important difference, crystalline solids are anisotropic in nature, anisotropic in nature, and amorphous solids are isotropic in nature. So what is anisotropic and isotropic? Anisotropic and isotropic, first you see isotropic. Isotropic means some physical properties of solids like uh, electrical resistance and refractive index. These are the physical properties of solids. Some physical properties like electrical resistance and refractive index values are same in all directions in the solids. That is called isotropic. So in the solid you go any direction, that physical properties values will be same. That is called isotropic. Iso means same, isotropic in nature. So some physical properties of solids like electrical resistance and refractive index values are same in all directions in the solids will be same. That's why this is amorphous solids are called isotropic in nature. Now anisotropic in nature, some physical properties like electrical resistance and refractive index values are different in different directions. That is called anisotropic in nature. So crystalline solids are anisotropic in nature, amorphous solids are isotropic in nature. So these are the major differences between crystalline and amorphous solids. Okay.